Hello. So can anybody hear me in the back? Just raise your hand if you can hear me. Awesome. All right, just let me restart my timer here because this one's off. There you go. So yeah, I'm going to talk about monitoring with Syslog and EventMachine. Quickly about me. My name is Patrick Huesler. Here's my Twitter and GitHub handle. I work for VUGA, which is a social game developer out of Berlin, Germany. We do social games, and they look like that. And they're mainly in Flash, and if you look at them, you are probably not the target audience. They are made to be easy, and so you could come back several times a day. And the recent project I've worked on is actually an HTML5 thing on mobile, so it's HTML5 thing on mobile. So it runs on an iPad, but it's just a website and it behaves like a game. So something more about VUGA. Social games, we're actually number 3 in the world on Facebook, just behind tiny small companies like Electronic Arts and Zynga. So I think we are doing okay with our 120 people. It used to be like 60 people a year ago when I started there. And just to give you some perspective on the user number, we have like, last time I checked a week ago, 6.5 million users every day that play our games. So, but back to my talk. I started writing my talk, and then I realized, Patrick, you actually went ahead and used the word monitor in your talk. What will people think when you say monitor? I was like, okay, Oxford Dictionary, what does monitor mean? And this is what it spit out. And long story short, this is a rather generic explanation. If you go to Wikipedia, you get lists and lists and lists of monitoring applications, like baby monitoring or chemical waste monitoring. It's like, okay, this is probably a bit ambiguous, so I need to narrow it down for you and give you guys some context. So, context for today is dashboards. Whoops, I almost tripped. I like dashboards, and the reason why I like dashboards, you're going to hear in this talk, you can do amazing things with it. And I like real-time-ish dashboards that display things in like, within a minute or so after the event happened. Doesn't be like instantly, a minute or so is okay. And to give you an idea what I'm talking about, early this year, we organized Euroco in Berlin, which is a Ruby conference. And we had like roughly 400 tickets, but the demand was much higher. So the first batch sold out within minutes. It was like 50 tickets. It sold out within minutes. People started freaking out. The ticket vendor wasn't equipped for that. So we thought like we could visualize it, because we to see what actually happens on the page and what's going on. Because we got some really nasty tweets. Some guy even mentioned a mob and a pitchfork to show up at the convention center because it didn't get any ticket. So it went even further, so we actually had RubyConf as a second conference that happens at the same time as the Ruby conference. So we could have more people because we couldn't fit in more people into the venue. So to give you an idea, we used a tool called Hummingbird to visualize the traffic just before the ticket sale. This is actually before. People went crazy, started writing Grease Monkey script on their browser to automate the ordering process, having several browsers, calling their friends, their father, everyone to get there. You can see it really good, probably from the back, but here, right now we're up to 67. Whoops, that came loose. I'm sorry, can everybody still hear me? My mic just came loose. Awesome. So there will be a moment where it will turn yellow on top. This is actually where it went crazy. And on the bottom, you will see even more dots. So you can clearly see people all over Europe actually tried. Here it happens. This is actually where it went ballistic. And I could go on. A few minutes later, the traffic will be like go to zero. So, and this got me kind of hooked. So then with somebody at our company thought of doing something else, actually tracking the number of users that are currently playing, but not just displaying the number, but also displaying their Facebook picture. So now you actually could see who's playing your game. We're like, all right, she might be cute, maybe, this is one of our users, awesome. But it's also a really good number, and also everybody knows, has a dashboard, and actually knows what's going on with your app. Sometimes people will come and like, our current users number just dropped by 1,000. And it's like, well, traffic pattern looks okay, but it looks like we have a problem. So a really impressive, really important number for us. Another thing is a dashboard that we have for Monster World, which is a game. And this is a more traditional one. It's not interactive. It just refreshes, I think, every 2 minutes. But this also can give you an idea of the scale we have. We're not Twitter scale. We're not Facebook scale. We're probably also not Heroku scale. I don't know how much traffic they do. But from my perspective, as a small guy from Switzerland, I think it's a lot. So for me, it's a lot. But in a bigger picture, in a grander picture, it's actually not that much. But still, also those numbers help us seeing what's going on. Especially if the new users would drop, we would know people can't install the game anymore. So to give you, to tell you what actually gave me the motivation to investigate further in how to build dashboards, how to gather those events in your application. One is DevOps, and the other thing is also, I was at a conference where guys from Etsy, which is a startup from the US, they gave a conference called Code as Craft. And one topic they would talk about was like, they monitor everything, they graph everything so they would know what's going on in their application. Why would they do that? Because they deploy several times a day. And everybody can deploy. Maybe not the cleaning lady, but other than that, everybody can deploy in this company. So, and with RubyConf, we have a thing called DevOps, so we also run your application, and also maintain it and be the operations guy. So you are on call and have to get up at 4 o'clock in the morning if things go wrong. So please, by show of hands, who is also running, maintaining, and is the system administration guys for the application he wrote? It's about half. That's good. It's good. Because I love it. I learned a lot about it. Because it got me thinking, how could I improve to have that moving target? That is my application. It's not like they would release a desktop application. You write it once, and you're done for a week or 2 weeks, and it's kind of frozen in its code base. You would release an extra update. With web apps, you just go, bam, here's an update. The users probably don't even notice it. So, but since you're moving so fast, things would probably fall down. I would love to know that in advance, right? When things start dropping, and maybe you have a leak. It's not broken, it's just leaking. And if it just would look at the traffic pattern, you probably wouldn't see it. So it would help me, I looked into what could help me debug it. And for instance, something like that would happen. You deploy a new release, and it's like, great new feature, you now do this and this and this. And then it turns out, sign up errors. People can no longer create an account on my application. Automatic tests probably were there, but for some reason they failed because we had sort of a Facebook integration, so maybe just Facebook integration failed. And all our testers probably already had an account, and nobody would even test sign up anymore because, well, I don't know, you forgot about it. So this would actually help you detect this. Because the traffic pattern probably might be fine, but your application for the users doesn't work anymore. Somebody steps on your money hose. If your web app makes money on like a minute or an hour base, you want to know if somebody stepped on your hose and it no longer generates money. You want to know this as quickly as you can. It's not like you can wait for a batch process, so the other day you will know, oh, yesterday you made 0 money. Probably not good, right? So one important thing. And generally it boils down to counting things. It's totally up to you, to the people that design the application, that run it, to know what's important of counting things. Here are a few examples. Concurrent users is actually one of my favorites, because it's just an indicator for me that something is wrong. Logins, signups, generally it's just errors. Now, let's assume we're gonna sketch up a system that will allow us to do this, to have this event tracking. That event gets emitted, and it ends up on a dashboard being displayed. You can look at it. So how would we do that? Now, without implying any special things, just like a rough sketch would be, let's assume we just triggered our events on the server side. We have an application server, so now this is Rails, maybe this isn't Rails, this is something else. And the event aggregation part is probably something. It could be a shared database, it could be a queuing system, it could be a messaging system, it could be all kinds of things. I don't want to decide this right now. I just want to have a rough spec. And also dashboard. I don't know about WebSockets at this point. All I want to have is just, it should display it at some point. So if I would define the criteria of such a system, which are the most important things? Simple will come into my mind. Why simple? I don't want no big packages to install. So this is just me, right? You probably have a different opinion, but if I would, in my humble opinion, I would say no package to install, no big dependencies or new things that I need to add just to have statistics that might break and take down my whole application because something went wrong. I don't want to have a complex transportation mechanism, not a complex format, like giant XML structures. I don't like that. And I don't want to invest a lot of money, because there is some software that does this for you, but is really, really expensive. And as a startup, probably you need to save money. So, real men and real women also walk away from explosions without ever looking back. That's a fact, according to some internet websites. But my idea is you should just fire and forget. You just fire the event, turn around and keep on doing what you were doing. You don't want to like fire and then go, it landed. Is it okay? Okay, you don't want to do this because this is time you spent waiting for things. You could do other things. And this can actually become a serious problem if it would be blocking. For instance, let's assume you have a shared database, so all your application servers write their events directly into a database. Let's just say MongoDB or Redis. And your applications is a Rails application. Now let's assume your shared database all of a sudden becomes slower and slower. That means your average response time gets slower. Because with Rails, you basically wait around. You're not evented I/O or anything. Or you just hang there and wait. So that makes your average response slower. And maybe if it dies, your request dies if you forgot to handle exceptions. So what will happen is, as slower and slower the database gets, is you just killed your whole application, because the queue will pile up and pile up because requests keep coming in, but you get slower and slower, so they cannot be handled in the time they should be. So somebody just stepped on your incoming traffic, so your application basically goes away and becomes unresponsive, in the worst possible scenario, of course. So here are the criteria again. It should be simple and lightweight. It should be polyglot. This one I didn't mention before. We use Erlang, we use Node.js, we use PHP, we use shell scripts. And I want all those to be able to fire out events without doing too much, right? And fire and forget, we had that. So I want to tell you a little story how I kind of got to the point where I would say Syslog and EventMachine. We wanted to use real New Relic and app performance analytics things. It gives you stats about requests per minute, requests per second, average response time, slowest action on a controller, stuff like that. It works turnkey out of the box for most Ruby things, rack compatible. It's amazing. But I was working on a project that was running Node. And the other guys were working on a project that were running Erlang, and they were not supported. So what do you do? I mean, first, of course, I was crying, and then I was like, well, that doesn't help. So what do you do? And then it was like on the verge of implementing a New Relic client in Node. And I looked at it, like, this takes weeks. No, I'm not going to do that. So, and I realized we actually use HA proxy as a load balancer, so to balance the traffic across all our Node.js instances. And HA proxy has log support, but it only has Syslog support. So you cannot tell it to log it to a file. You actually have to activate Syslog, which, if you don't know what Syslog is, I will talk about it later. So, and HA proxy gives me those powerful numbers that I need for my New Relic. Those here. They basically tell you the number of seconds, number of milliseconds that happened before the request could be processed. So if you received enough HTTP to actually start processing, the number of times spent in the queue before it would be handled by the application server, the time that the application server took to respond, and the total time. So those are the numbers that we're interested in. I need to get hold of this. And I didn't want to run on the same machine like HA proxy, because if I do something wrong with my parsing routine, I would take down the load balancer, and I would take down the whole application. Probably not a good idea. So I wrote this, right? And I was like, okay, I'll just write something, a custom syslog server, and tell HA proxy just to log to me on a different machine. I will parse those logs, do some magic with it, and use the New Relic Ruby agent that they give you away as a gem. It's open source. Sift it through the code for a couple of days see how that thing works, figure out the places I need to hook in, and pass it into New Relic, and voila. This was born, and this does exactly that, and we use it for our Erlang and for our Node.js thing, and it works quite nice. We can improve it and add more methods to it. But bottom line is, it got me thinking, like Syslog. Why haven't I noticed you earlier? I have used you, and system administrator have told me all along. They have used it since the 80s. Like, well, you're a little slow sometimes, Patrick. It's okay. So, Syslog. It ships with every Linux, with every Unix. And it's quite simple. You have a facility which is basically, you tell it to be a daemon or a cron or a user. If you would look into your file system on a Unix or a Linux, if you were to go like /var/log, you would find daemon, cron, user.log, but also like local facilities. And the other one is level, right? Is a priority, is an alert or not? You can do client server, you can do all sorts of funky things. And as a big +1 for lightweight and simple, they actually had this in mind. They said, yeah, I want to have the devices that otherwise wouldn't be able to communicate with a bigger system to actually tell me about what's going on about events. So here's the format. That's another one. That's, I mean, you can look at it, and this is the whole specification of a format. I like that. And with message, I can pretty much do whatever I want. I can pack in JSON, my own custom format. If you go crazy, you go XML, but you can do what you want. So, and then UDP, and I'm like, Syslog is using UDP. They also provide TCP, but they're using UDP for a reason. UDP was actually made for exactly that purpose. Because at some point, neglected to mention it, at some point I decided I don't care if the event that I send out is never received. Because I can deal with that. I mean, we will have some problem, but I'll be able to fix that. But I want to work like that. It's not a big deal if event or two are missing. So UDP is the big, tough man here that actually just walks away from explosion. TCP is waiting and looking and like, all right, it burned down, thank you. And UDP just walks away. And I think that's nice. So if you check up on that, we see, all right, simple and lightweight, Syslog takes care of that. Polyglot, Syslog takes care of that. Fire and forget, UDP takes care of that. So much so good. Let's finally build it. This would be a simple one where just bypass syslaws and do the UDP version, which is often just fine. It's a really good idea just to do that if you don't need the Syslog functionality. Actually, a few systems actually work like that. They use UDP with their custom data format. Right. I decided to go with this so we can, 10 minutes, thanks. So we can go locally, just log locally. The application server would log locally, and then Syslog will take care of relaying the messages to a different server and storing in log files so they could be replayed at some point. So I wanted to have this. So it gives me a bit more power over the whole thing. And if as an event source, well, you could write Ruby, or you can use this funny little tool called Logger. It comes with every Unix. Try it out on your Mac right now. Go Logger, do something, and check your console. It's there. So that's a big plus on lightweight, because you don't need to do anything if you don't want to. But you could also implement it in Ruby using their Syslog API, which I take is probably one of the worst documented bits ever. You have to Google it, and maybe somebody figured it out. I didn't. I maybe just took the code and adapted it a little bit so it would work. It's also quite hard to test. I mean, how would you do that? Yeah, Syslog, but this would be like an implementation of it. It's kind of weird that you need to write your own wrapper function to do Syslog, but that's okay. So for the server part, what we need to do is listen to UDP. We could also just tail a log file, but let's go nuts and listen to UDP. And receive and parse Syslog messages and update some sort of a counter and have an internal data structure. But we'll keep it simple there. So here's the EventMachine part. I decided to do an EventMachine because it's so easy to do. That was actually the only reasoning behind that. EventMachine has other benefits, and at this point actually doesn't hurt what I'm doing. So yeah, the server bit is all at the bottom. Can everybody see? Everybody should be able to see that. So it's basically a one-liner inside the EventMachine event loop to tell it to open a datagram socket. And you need to have a handler. That's a method that has a receive data method. And you're good. And if you don't want to implement your own Syslog parser, you don't have to. Sometimes you don't even need a Syslog parser. I think at some point, in some applications that don't even have a Syslog parser, I just do like splits on spaces, and I don't care about the date and everything. But somebody has done it. Now let's do WebSockets, because it's just not cool if you have a dashboard that doesn't have WebSockets. So just because we can, let's do it. Not because we need it, because we could just like refresh, auto-refresh the page. It would work just as good. But it wouldn't be hip, and I don't know. I'm a bit of a hipster when it comes to that, probably. So, and because I can, this is the WebSocket bit. So there are like two really important parts. One is we just create a channel, an EM channel, which is a publish-subscriber thing. So clients can subscribe to it, and if you push to that channel, all the clients will receive it. So classic publish-subscriber mechanism. And this part here is, yeah. This is how we start, and then you buy the events, tell it what to do. If a client opens a connection, you tell it to subscribe with the message. And if you unsubscribe, if they close it, you unsubscribe them from the channel. So that's actually quite straightforward. But remember the email channel part here. So what we need to do now is we need to tell our UDP server that takes in all the events that come from somewhere. We need to tell it where it can get a hold of that EM channel so it can push out new notifications. Okay, I don't know if this is like the best architecture for now, but just for simplicity's sake, let's just say it has a reference to a EM channel which it can push notifications out. So all the dashboards that are connected to it would receive it. And this would be it. What you can do is with EM connection, you just like squat the arguments as an array. and then you get in, as a first argument, you would get in the channel and this, and then you would initialize a new counter, which because obviously you're counting things, right? And then if you receive data, we update a counter, and let's just say we push that new counter value. We could also just push the difference, but that would kind of make it a bit complicated because not every client might have the same value of your counter. So to keep it simple, just push out the new value and tell the client to replace that value. Yeah, I kind of skipped over something. Yeah, I skipped over this bit. How would you pass in the reference to the channel to your UDP server? You just pass it in as the last arguments to datagram socket, and it will come in as args. Just for completion's sake, this would be the standard client browser implementation that probably does not work across browsers, but it's a dashboard. And it's my dashboard, so I can use whatever browser I want. And I'm not going to use IE 6 or 7 or 8. So this is, it works in Safari and Chrome. So, but there you can go nuts and do whatever you want. But I think you get the idea how simple is that. What else? I mean, there's a lot more you can do. And stuff I still also want to build into our system, and at some point release sort of a framework thing for you guys, open source. But I'm having a few problems finding the right abstractions, because you have seen it, like the basics are so simple, it's really hard to define the right abstractions without like restricting the users too much. But what can we add is graphing. I mean, you could have an event machine timer that would go like every 2 minutes. It would gather certain stats, and then it will use a thing called, for instance, Graphite, and call a Graphite command line tool, and give it the data, and it would generate the graphs, and you could display it in your dashboard.
Basically, this is what we did. Just to have an idea of what we were working on yesterday before the lights went out. We had a system like this in place, so we could fire events in the background to a system aggregator through Syslog, and then for somehow magically displayed on a dashboard. So this is the EventMachine server part. Again, it's so easy to open a datagram socket. And regarding the WebSocket part that I talked about yesterday, I kind of forgot that sometime in the meantime, while I was writing this talk and while we continued working on our dashboards, we actually changed the implementation. And it wasn't until yesterday when Konstantin told me that we better should look into server-side push events, which is another form sort of WebSocket, but it's just one way. It's the server pushes up to the dashboard. So instead of using those WebSockets, one could use server-side push events, which would be a way more efficient way of doing this, because hardly ever your dashboard will communicate directly with your server. Ideally, just push out data to the dashboard and tell it to whatever you want to do with it. Here's your data. Draw a fancy graph. I don't know. Call my parents. Do whatever. I don't care. So they are called server-side push events. We actually use it in the dashboard that I showed you guys initially. Here's one. Here we go. It's like a movie, right? I'm just like skipping really fast. A flashback of what happened last night. So this one is actually done with server-side push events and not traditional WebSockets. And we use that. Actually, we built that in Erlang. That's not even a Ruby thing. We built that in Erlang, just in case I forgot to mention that. How much time do you have left? I have 3 minutes. Awesome. So I want to look back at a few things. Fire and forget part, I think, is one of the most important part of what I talked about yesterday. This what I think event systems should be if you get events in the back end. You should just fire away, don't care, walk away, keep on doing what you wanted to do. And the non-blocking bit, because you don't want your event system to take down your whole application just because your database went slow, or a service that you write your tracking calls to goes really slow, and it impacts you, and then it impacts your application, it impacts your users, and at some point you end up with a big bang and nothing works anymore. So I think that's also a really important part, and those are the 3 criteria that I made up. You probably have different ones, but those are the ones that I used. Because I want things to be as simple as possible, should work with as many languages as possible without writing a library for everyone, for each and every language, and the whole fire and forget non-blocking part. So now to the end of my talk. Graphing. I think this is where I stopped yesterday. So you can attach it you can either generate graphs on the server side with that system. A UDP message comes in from Syslog, you parse it, you increment a counter, and then you could, in certain interval, take all your counters that you gathered somewhere in memory or in a database or on a file, depending on implementation. You take all those and you push those value into an round-robin database like Graphite, and it would generate a graph for you, like offline, but you could also like push that up through a push socket to a dashboard, and the dashboard will do the graphing. So it really depends on what you want to do. What you also could do is what the guys did on another project. What they did, they wanted to have a really mathematically complex graphing thing. So what they did is they used R, the programming language R, to generate all the math and all the values, and then use something like gnuplot to generate really complex graphs that you normally wouldn't do with like regular graphing solutions. And most importantly, I want to build the things. I started actually building a thing called Yada, and it's pretty much a rip-off from StatsD. StatsD is most of what we talked about yesterday and today, written by the guys from Etsy, and it's written in Node.js. What I did not like about StatsD is they kind of define what you have to do. They basically define that you have to use a counter format and you count things, which is okay in most cases. I do agree, but I also think that you should. Is that a 1? I don't even see it. Okay. That I want it to be more open. I want it to be the users to define their format and do custom things if they want to. So I actually started porting StatsD to Ruby in a more generic way. This is actually the tricky part. I wanted to come here and give you a framework. Well, here's Yada. Problem is, it's really hard to make it generic enough so everybody can use it, but also not too restrictive. So I haven't found a good API and a good balance yet. As soon as I have that, I will show it to you guys. But also looking for help from you. If you want to have some more inspiration about what I've talked about today, is read things from the code as graph from Etsy, Measure Anything, and a blog post from Flickr, and look at the date. It's 2008, right? There we go. Counting and timing. So they already said, well, let's do UDP and let's do a lot of graphing and counting. So the Flickr blog has a lot of great insights. Yeah, now that's it. Thank you very much. Yeah, the slides will be up there on our Vuga account. And we're always looking for great people. So, your questions? Hi.
I got a question. All you did is great. I think it's for real-time monitoring, right?
Yeah, pretty much, yeah. But you could also hook it up to some offline asynchronous batch processing if you want to. But in essence, yes.
That's really my question. So did you not maintain a history of events? Or
At this point, we don't, no. I mean, what you can do is you can have graphs with a feature like compare to last week that you can build, which is sometimes important. But at this point, we don't. No, we don't store the history. But it actually would be easy. Since you're using Syslog, you just store the log files. Tell Syslog to store the log files and also relay them to you. So you would have a history of things.
okay, great.
I think you mentioned yesterday that you built the system in part because testing with Facebook, with the interaction with the Facebook API is something difficult to do. I'm also developing Facebook applications, and I was wondering how you manage to actually test your applications regarding the interaction with the Facebook API.
First, I mean, yes, the testing part is really hard, but sometimes when you run your tests, it might work nicely. Assuming you have nice tests for Facebook, it might run nicely. But in production, at some point, Facebook might have a problem, and then you don't help there. So actually, that's what what you can use it for. Regarding your question, testing Facebook app integration, that's really tricky. Either you can go generate Facebook test users and do like full stack integration tests by using their test user API, or you can mock everything out with the chance that you miss changes in Facebook's API. So you need to find the right path. But we also have every now and then actual people that do the installation process manually to check if everything works as expected. So it's a really tough nut to crack, and it depends on you how deep you want to go. I suggest you do it on several levels, so like a unit mock level, but also to really be sure have an integration level sort of things to test it out, depending on how heavy you rely on Facebook, or if it's okay and Facebook just is not there, your app is running nicely, then I wouldn't care too much about it, I guess.
Thank you.
Hi, here.
I'm confused. Hey, how are you doing?
Hi, fine. How are you?
I'm good.
Great.
Coffee.
Thank you very much for the talk. It was great.
Thank you. Thank you.
I wanted to ask you, when you had that counter, that 4,000 something running, I think it was people playing or...
Yeah.
Okay, how do you know that number, 4,000 and something, it's the right number? I mean, you have that in a panel at your office, and you know that it should be 4,000 and something, or you understand the question?
Yeah, I mean, you could start. What we also do, what I didn't show, is we graph that number somewhere else in a different dashboard. So you can compare it with yesterday. So you would know if your number is like really off or not. And you also, by experience, you would know if it's like really going really good or really bad. But most of the time, it doesn't really matter that you know that the number is correct. It's the tendency that counts. So if it goes up really quickly, you know something is up. If it goes down really quickly, you know something is up. Actually, the value, the amount of the money, the number doesn't really matter in terms of debugging. You just want to know, is it stable, is it going up, or is it going rapidly down?
Okay. And something else. When you said you replaced WebSockets for some kind of server push, is that HTML5 or what?
Yes.
Okay.
It's a special HTML5 push thing. I mean, I will update the slides before I upload it, so you can read it there. We actually, it's actually even more simple than traditional WebSockets. It's a bit more limited in its use, but it's really powerful for that particular use case. So yes, HTML5 standard.
Thank you very much.
Okay.
¿Otra pregunta? Bueno, muchas gracias.